Welcome to the DIY Honda Garage channel. The DTC Diagnostic Trouble Code P16E2 signifies a PGM-FI-ACG LIN communication error in Honda HRV models from 2016 to 2022. This error indicates that there is a communication failure within the LIN, local interconnect network, related to the Powertrain Control Module, PCM, and the alternator. Proper functioning of the communication systems is crucial in modern vehicles, as they ensure that various electronic units can communicate effectively. Depending on the severity, this fault may result in performance issues or could prevent the vehicle from starting altogether. Understanding the components involved is essential, as the LIN system connects multiple sensors and modules, including the alternator and the battery sensor, which communicate vital operational information. During fault detection, it's advised to start with thorough inspections of connectors and wiring that might contribute to the problem. The DTC P16E2 specifically points to a communication error within the LIN, local interconnect network, involving the PGM-FI, programmed fuel injection system. The primary components affected by this error are the Powertrain Control Module, PCM, and the alternator. The PCM is responsible for managing vehicle functions, including fuel injection timing and air-fuel ratios, while the alternator provides the necessary electrical power for the vehicle systems. This particular communication error can often be attributed to loose or corroded electrical connectors, especially at the alternator and PCM themselves. For the HRV, these components are typically located under the hood near the battery area. Any failure in communication may result in the engine running improperly or fail to start, necessitating immediate attention. Several factors can contribute to the P16E2 DTC message. One of the most common causes is a loose or corroded terminal connection at the alternator, specifically at the positive plus B terminal. This connection is essential for providing the correct voltage and enabling communication to other vehicle systems. Another possible cause could be a malfunctioning PCM, which can disrupt multiple communication pathways within the vehicle. Additionally, issues with the LIN wire itself can result from damage or shorts, which would prevent proper data transfer between components. Lastly, a faulty battery sensor might hinder communication as it interacts directly with both the alternator and the PCM, potentially leading to erroneous readings and triggering the DTC. The symptoms associated with DTC P16E2 can range from minor issues to severe operational problems. Drivers may notice engine performance issues such as misfires or poor acceleration, as the communication failure might affect system timings. Starting problems can also manifest, with the vehicle struggling to turn over. This code typically generates a stored DTC in the vehicle's memory, which can be accessed via a scan tool. The malfunction indicator light, commonly known as the check engine light, may also illuminate on the dashboard, indicating that there is a need for diagnostic testing. If not addressed promptly, these symptoms can lead to more extensive damage within the vehicle's systems. The first step in troubleshooting the P16E2 DTC involves verifying the problem using the Honda Diagnostic System, HDS. Start by turning the vehicle to the on mode, which powers up the electronic systems without starting the engine. This allows for clear communication with the onboard diagnostic systems. Next, use the HDS to clear any stored diagnostic trouble codes. After clearing the DTC, it is crucial to wait for approximately 10 seconds to ensure that the system resets properly. After the waiting period, check again for any pending or confirmed DTCs using the HDS. This step helps in determining if the error is recurrent or an intermittent issue. In the second troubleshooting step, The focus is on checking for any pending DTCs alongside the confirmed DTCs using the HDS. If DTC P16E2 is indicated, it confirms that the issue has been duplicated successfully, allowing the technician to proceed to the next step. If P16E2 is not present, it may indicate an intermittent failure in the system, suggesting that the communication error is not constant. In such cases, it's advisable to check for poor connections and ensure that all terminals at both the alternator and the PCM are securely connected. Additionally, if there is freeze frame data or an onboard snapshot available, attempt to replicate the failure conditions documented in this data to further diagnose the problem. In Troubleshooting Step 3, you will be investigating potential failure areas by first turning the vehicle to the off or lock mode to ensure safety. Disconnect the alternator 1P connector, which connects the alternator to the main wiring harness. The next step involves checking for continuity between two specified test points: the alternator 1P connector, number 1, and the vehicle's body ground. For a proper assessment, this check needs to be performed with the vehicle off. If continuity exists, it indicates that there is likely no short at this juncture, allowing you to progress to further troubleshooting steps. If continuity does not exist, it suggests a possible open circuit or disconnection within the wiring that needs immediate attention. Step 4 of the troubleshooting process involves a detailed assessment of the LIN wire for shorts. The first action is to jump the SCS, Service Check Signal line, with the HDS to facilitate testing. After this, while observing continuity between the alternator 1P connector terminal and body ground, disconnect specified connectors one at a time, including the 12-volt battery sensor 3P connector and the PCM connector B, 51P. The goal here is to determine whether the continuity ceases when one of these connectors is disconnected, which would indicate that the LIN wire is functioning correctly. Its continuity disappears upon disconnection. It means that a short exists in the wiring, specifically between the alternator, the battery sensor, and the PCM, requiring that section to be repaired accordingly. At this stage, you will be determining additional possible failure points in the LIN circuit. Begin by reconnecting the alternator 1P connector to restore its functionality. Next, disconnect the 12-volt battery sensor 3P connector. The main task now is to check for continuity between the battery sensor 3P connector number 3 and the body ground. Like previous tests, ensure that the vehicle is in the off or lock mode while performing this continuity test. A finding of continuity in this test indicates that the alternator is at fault and should be replaced to restore communication between the systems. If no continuity is found, however, continue to Step 6 for more diagnostic measures. During Troubleshooting Step 6, you will perform an open wire check on the LIN line. First, jump the SCS line with the HDS as previously done. Follow this by disconnecting the alternator 1P connector and the PCM connector B, 51P. With both connectors disconnected, check for continuity between the alternator 1P connector number 1 and the PCM connector B, 51P, number 31. If continuity is present, this indicates the LIN wire is not faulty. Further actions should include updating the PCM software to its latest version or substituting it with a known good unit. If the DTC P16E2 resolves itself after these actions, troubleshooting is complete. But if it stays persistent after replacement or updating, the original PCM must be replaced to guarantee proper functionality. The final troubleshooting step reiterates the importance of continuity checks. Start by ensuring the vehicle is turned to the off or lock position. As done in previous steps, jump the SCS line with the HDS for reliable testing outcomes. Disconnect both the Alternator 1P connector and the PCM connector B51P to ensure that the circuit can be accurately tested. Again, check for continuity between the specified test points. PCM connector B51P. No, 31, and Alternator 1P connector number 1. If continuity exists, it confirms the LIN wire is indeed functional. However, if it does not exist, an open circuit likely exists in the LIN wiring between the PCM and the alternator, necessitating repair to restore proper communication functionality. After completing all necessary repairs based on the prior troubleshooting steps for DTC P16E2, verification is critical. Start by confirming that the original issue has been resolved and ensure that all links in the communication pathway are secure. It is essential to check for any remaining DTCs to ensure that the vehicle is operating normally. Run a test drive to assess the overall vehicle functionality and to see if any symptoms recur that might indicate other hidden issues. Proper documentation of all repairs should also occur to maintain vehicle history for future diagnostics. Adequate verification prevents premature closure on the issue and ensures full vehicle functionality is restored. To prevent the occurrence of issues like DTC P16E2 in the future, several proactive maintenance tasks should be instituted. Regular inspections of connectors, especially those related to the alternator and PCM, can thwart problems caused by corrosion and loose fittings. Routine checks on intricate wiring systems can also prevent damage and ensure that components remain connected without issues. Additionally, remaining informed about updates to dealer-recommended PCM software is essential. Software updates can fix known issues or improve communication in the LIN network, thus mitigating errors before they manifest significantly in vehicle performance. In conclusion, addressing DTC P16E2 requires a thorough understanding of the symptoms, possible causes, and a systematic approach to troubleshooting. This includes verifying connections, checking for shorts, and assessing wiring integrity within the LIN communication system. Following the outlined steps in troubleshooting ensures a methodical diagnosis that can lead to effective repairs. Additionally, the implementation of preventive maintenance strategies will help in avoiding future issues, thereby enhancing the long-term reliability of your Honda HRV. Understanding these factors is essential for any technician working on modern vehicles equipped with complex electronic communication systems. Please like and subscribe to the channel. See you next time!